Welcome to Listen and Learn Code. In this episode, we will talk about design patterns, focusing on how they work with Python. My name is Michael, and today we start learning about some important design patterns that every Python developer should know. This is our introduction episode, where we will explain what design patterns are and why they are important in development. Design patterns are not just abstract concepts, they are practical, time-tested solutions to common problems in software design. They give us a shared vocabulary to discuss solutions and help us build more robust, maintainable, and scalable applications. When you design object-oriented software, you need to identify the right objects, decide how to group them into classes, define how those classes will interact with each other, and set up the relationships between them. Your design needs to solve the problem you're working on right now, but it should also be flexible enough to handle future problems and changes that might come up. The goal is to avoid having to redesign everything from scratch later on, or at least minimize the amount of redesign you need to do. Programmers can feel overwhelmed by the many choices they have to make. It takes time for beginners to truly understand what makes a good object-oriented design. Experienced programmers have a knowledge and experience that beginners lack. They don't need to solve every problem from scratch. Instead, they reuse solutions that have worked well for them in the past. When they find a good solution, they use it over and over again. This practice is part of what makes them experts. As a result, you'll often see recurring patterns in many object-oriented systems, patterns of classes and objects that communicate with each other in specific ways. These patterns solve common design problems and make object-oriented designs more flexible, elegant, and reusable. They allow programmers to build new designs based on previous successful experiences. A programmer who knows these patterns can apply them to new design problems without having to figure everything out from the ground up. We all recognize the value of experience in design. How many times have you encountered a problem and felt like you've solved something similar before, but couldn't quite remember the details? If you could tell exactly how you dealt with a previous problem, you could reuse that solution instead of starting from scratch. Unfortunately, we often don't do a great job of documenting our design experiences in a way that others can easily use. This is why understanding and using design patterns is important. They capture and share valuable design experience, allowing you to benefit from the solutions that others have already discovered and refined. To help explain this concept, think of it like cooking. Chefs don't always invent new recipes from scratch. Instead, they often rely on familiar techniques and favorite combinations. For example, they might use the searing and roasting technique for meats, where the meat is first browned in a hot pan and then finished in the oven. This method is used in countless recipes because it reliably produces a juicy, flavorful dish. Similarly, they might use a base flavor trio, like onions, carrots, and celery, to start soups, stews, and sauces, which is a foundation in many different cuisines. In the same way, in software design, object-oriented designers use established patterns like representing states with objects or decorating objects to easily add or remove features. Once you understand these patterns, just like a chef understands cooking techniques, many of the decisions in your design process will become more straightforward. You'll know when to use a certain pattern or technique because it has worked well in similar situations before. This approach not only makes your work more efficient, but also leads to a more reliable and refined final product. Imagine you're organizing a big wedding, and over time, you've developed a reliable method for making sure everything goes smoothly. You found that it's best to start by choosing the venue, then selecting the caterer, planning the decorations, and finally scheduling the day's events. You might also decide to group your tasks by category, like venue arrangements, food and drinks, and guest coordination, and then plan each group according to its priority and timeline. This method becomes your go-to strategy whenever you plan a new event. Now, in the same way, when we talk about design patterns in software, we're talking about proven strategies for tackling common problems that come up during the design process. Just like your wedding planning method, a design pattern gives you a reliable approach that you can use in different situations. A design pattern has four main parts. First, the pattern name. Just like we might call our wedding planning method the venue first approach, a design pattern has a name that sums up the problem it solves and the way it solves it. This name helps us communicate quickly with others. For example, if you tell someone you're using the venue first approach for wedding planning, they'll immediately understand the general strategy you're using. In software, having names for patterns allows developers to discuss ideas more easily, share knowledge, and think about design in a more abstract way, without getting bogged down in the details right away. Next, we have the problem. This is where we define when and why we would use the pattern. Going back to our wedding example, the problem might be, how do we ensure that all elements of the wedding day are coordinated smoothly? The design pattern explains the problem it addresses, like how to manage the flow of events throughout the day or how to handle changes in the guest list. It might even include specific conditions, like needing a plan that works for both large and small weddings. The third part is the solution. This is the core of the pattern. It's not a detailed, step-by-step set of instructions, but more like a general recipe or template that can be adapted to different situations. For example, in our wedding, the solution might be book the venue first, then handle catering and decorations, and finally focus on the event schedule. This solution can be applied to many different weddings, no matter the size or style, with adjustments as needed. In software design, the solution tells us how to structure our code, how the different parts of the program should work together to solve the problem. Finally, we have the consequences. These are the results of using the pattern, both good and bad. In our wedding example, a positive consequence might be that the event runs smoothly and guests are happy, but a trade-off might be that it requires more upfront planning and coordination. Understanding the consequences helps you decide whether the pattern is right for your situation. In software, consequences might involve trade-offs in performance, resource usage, or how easy it will be to adapt the system later. Knowing these consequences helps developers make informed decisions about whether to use a particular pattern. Design patterns aren't about specific, ready-to-use solutions like a pre-packaged wedding planning template. Instead, they're more about the strategies for solving common design problems in a flexible, reusable way. They help identify which parts of the system are doing what, how they interact, and what responsibilities each part has. Each pattern focuses on a specific problem and discusses when it's appropriate to use that pattern, considering the trade-offs involved. By using these patterns, developers can build systems that are easier to maintain, extend, and reuse in the future. Design patterns are divided into three main categories: creational, structural, and behavioral. Creational patterns are focused on the process of object creation, providing ways to create objects in a manner suitable to the situation. These patterns help ensure that objects are created in a way that is efficient and adaptable to change. Structural patterns deal with the composition of classes and objects. They help you organize different parts of a system, ensuring that components work together harmoniously and efficiently. Behavioral patterns focus on communication between objects and classes. They define how objects interact with each other, ensuring that responsibilities are distributed in a way that allows the system to function smoothly and respond to change. Now, to make these categories more relatable, let's illustrate them using the example of planning a dinner party. Organizing a successful dinner party involves several steps, from preparing individual dishes to making sure everything is served at the right time. This process can be compared to how different design patterns work together to solve problems in software design. First, think about the creational patterns. These are like the techniques you use to prepare the main components of your meal. For example, let's say you're making pasta from scratch. The process of mixing the ingredients, kneading the dough, and rolling it out into sheets is like a creational pattern in software design. It's a method that helps you create something essential from raw materials. Just as you might follow a specific technique to ensure your pasta dough turns out perfectly, creational patterns guide you in creating the foundational objects or components in your software. Next, we move on to structural patterns. These are like the techniques you use to put together different parts of your meal. Imagine you've made your pasta, cooked a sauce, and prepared some toppings. Now, you need to assemble these components into a complete dish, like layering a lasagna or arranging a beautiful pasta platter. This step is similar to structural patterns in software, where you take different parts of your program and organize them into a cohesive whole. Structural patterns help you combine these elements in a way that makes sense, ensuring that everything fits together nicely, just like how you would carefully assemble the layers of a lasagna. Finally, we have behavioral patterns, which are like the process of coordinating the entire dinner party. Imagine you've prepared all your dishes, the pasta is ready, the salad is dressed, and the dessert is chilling in the fridge. Now, you need to think about how to serve everything in the right order. You want to make sure the salad is served first, followed by the main course while it's still hot, and then finish with dessert. Behavioral patterns are like this timing and coordination. They help you manage how different parts of your software interact with each other and when certain actions should take place. Just as you plan the sequence of serving dishes to create a smooth dining experience, behavioral patterns guide how your program's components work together to achieve the desired outcome. So, in this dinner party analogy, creational patterns are the methods you use to prepare the individual ingredients. Structural patterns are how you assemble those ingredients into complete dishes, and behavioral patterns are how you orchestrate the serving of the entire meal to ensure everything comes together perfectly. Each pattern plays a crucial role in making sure the dinner party or your software runs smoothly and successfully. Design patterns should be seen as tools in your developer toolkit. They provide mental models or frameworks that help you think through and solve common problems in software design. However, they are not rigid blueprints that must be followed to the letter. Instead, they offer guidance and suggestions based on best practices, but you should adapt them to fit the specific context and needs of your project. Design patterns provide a clear, structured way to organize code, making it easier for developers to understand. When code is organized around a well-known pattern, it becomes more intuitive for others to read and follow. By breaking down complex logic into smaller, well-defined components, design patterns make it easier to modify and extend the code over time. Design patterns help encapsulate complex logic into manageable pieces. Instead of having a monolithic block of code that does everything, patterns guide you in separating concerns, organizing responsibilities, and isolating changes. This division makes it easier to reason about the system and maintain it over time. Design patterns offer a common vocabulary that developers can use to describe solutions to common problems. For example, if someone says they are using a factory method or a singleton, other developers familiar with these patterns will immediately understand the approach being taken. Using design patterns leads to a more consistent approach to solving similar problems across a code base. This consistency makes the code easier to understand and making it more straightforward to onboard new developers. It's important to remain flexible when applying design patterns. Every project and problem is unique, and sometimes deviating from a standard pattern or combining elements of multiple patterns will yield a better solution. The key is to understand the principles behind the patterns and then apply them creatively. While design patterns can help manage complexity, overusing them or applying them inappropriately can lead to over-engineering. It's crucial to keep your solutions as simple as possible while still addressing the problem effectively. The goal is to improve the design without adding unnecessary layers of abstraction or complexity. Sometimes a straightforward, less formal approach may be more appropriate than a complex design pattern. If a pattern feels like overkill for the problem at hand, it's perfectly fine to go for a simpler solution that is easier to implement and maintain. Your experience as a developer plays a critical role in deciding when and how to use design patterns. Over time, you'll develop a sense for when a particular pattern is appropriate and when it might be better to take a different approach. This judgment comes from understanding both the problem domain and the implications of using specific patterns. Striking the right balance between following patterns and applying your own insights is key. Use design patterns as a starting point or inspiration, but don't be afraid to modify or even disregard them if they don't fit the specific needs of your project. Many design patterns are designed to address issues that arise as software systems grow in size and complexity. They help ensure that the code remains scalable and flexible, allowing it to adapt to changing requirements without becoming overly complicated. By following these patterns, developers can avoid common pitfalls and adopt approaches that are known to work well in practice. Design patterns make it easier to refactor code because they provide a clear structure that can be adapted as requirements change. If a system needs to evolve, patterns offer a roadmap for making changes without disrupting the entire code base. Patterns like the factory method, strategy, and observer are specifically designed to allow for changes in the system, like adding new behaviors or formats, with minimal impact on existing code. This makes the system more resilient to change and easier to extend. Today, we talked about how design patterns help manage the challenges that come with building bigger software projects. In this first episode, we've introduced why design patterns are important. In the next episodes, we will look closely at specific patterns like the factory method, strategy, and observer. Thank you for joining me today. I'm excited to continue this journey with you in the next episode of Listen and Learn Code.